Good afternoon. Today we're going to be talking about dependency properties, dependency objects, framework objects. What are dependency properties? Let's jump to our code. We've actually been using dependency properties for quite a while now. For example, this docPanel.doc is a dependency property. And notice that we are using that property in the button, in the list view, in the text box, in the stack panel, so all these disparate classes. And I've told you before that these are properties that we're setting. So where is that property coming from? Well, if we jump into the documentation for the button class, we can dig through all of this documentation and we will not find a docPanel.doc property. And that's because it just doesn't exist on the button. But what is, and if we dig through our inheritance, look at our button base, our context controller, our control, our framework element, all the way back, we also won't find it in any of the classes it inherits from. So where is it actually coming from? Well, it is actually defined in the docPanel class. And it's defined as a dependency property, which is a different way of implementing properties than we've dealt with before. And that all ties back to this dependency object, which is the base class of all dependency objects. And what does it do? Well, it actually adds a couple things. You look in here, a couple properties, but really the methods are the important ones. And this set value and this get value are the two most crucial. Those actually will set or retrieve a value that's stored essentially in a dictionary. And a dictionary, as you know, is just key value pairs. So a dependency property is the key. The value is whatever you set it to. And if we go back to our code, we will see, in this case, the key is docPanel.doc, and the value is bottom, bottom, or top, or left, or right. So just the various orientations we can dock to. So what is this really all about? Why would we want a dictionary of properties? Well, the benefit is exactly what we see here. We can add properties to an object that doesn't have those properties defined. And this is something that if you've come from JavaScript, you've come from Python, you're used to. You can add properties to any object you want to. It doesn't have to be part of the original class definition. However, in static classes like C#, static languages, we do have to define everything up front. So this is really a workaround to add some of that dynamic language nature into dependency objects so that they can add extra properties that aren't defined in that object itself. So this is an interesting way of bringing dynamic programming into a static programming language. And it gives us a lot of power once we kind of get our heads around it. But it does take a little bit to get your head around. So up to this point, we've got our code working where we're displaying a shopping list. We can add things to that shopping list. And we have this bound checkbox that says whether or not we've found an item. So we can do all of those things. But if we go back to our line item, you'll notice that we actually have a quantity property defined there, which is how many of that item we want to get from the grocery store or whatever store we're shopping in. So ideally, we'd want to add a quantity control to this list so that we can keep track of how many items we actually wanted to go get. And to do that, we're going to create our own framework object, dependency object, which is a custom control. And let's call that account box. So if we go to shopping list of the project, and we go to add, and we're going to add a new user control, WPF. And we're going to call this one count box. And you've probably seen, as you've been learning your WPF controls, that there are a lot of controls that basically are the same name, like a view and a box version. So the a list view, a list box, a text view, a text box. What the difference is, except the text view is actually a text block, but the rest of them are views. A view control is one that is read-only, that's just displaying information and updating, but you can't make changes to it as a user. And then the box versions are the ones that you can make changes to. And since this is indicating a count that we can change the quantity of, we're going to use a box as part of the name, so count box. And that's just a convention. It's not something you necessarily have to follow. And just to make this a little more legible for you guys, I'm going to go ahead and split the screen horizontally. And I'm going to change this design height because this is meant to go in a single line to something like 500 by 200. Now again, those are the design height. That is not how big the final control will be rendered, but that's how we're going to render it in our little design view over here at that size. and we have a grid, and I really want in this grid a text box, which is going to display a count, and 2 buttons, a plus and a minus, that are going to increment and decrement. So that calls for 3 columns. So grid.column definition, and I'm going to put 3 column definitions in there. And I'm going to put the decrement on the left because we probably won't use that very often. I'm going to put the increment on the right, and I'm going to put the number right in the middle. That helps if we're using fingers that we're not accidentally hitting the decrement when we meant the increment. And I want that text box to be a little bit wider than the rest. So I'm going to set its width to be twice the size of the other buttons. And I'm going to go ahead and put a minimum width on this grid as well, just to say I don't want it to fall under 200 pixels. So it will always be at least 200, and it can be bigger, but that'll keep it from being smushed, because some controls will actually try to smush it if it doesn't have a specified minimum width or minimum height. In fact, I could also do that for the height. I'll leave the height alone. I'll let it be squished a little bit if it needs to be. Okay, now inside the grid, I'm going to just define a button for making the number smaller, so the decrement button, and that's going to have a minus sign, and I'll say grid.column and set that equal to 0, so it's in the first column, or the 0th column, because we use 0 index numbers here. And you'll notice there's another use of a dependency property. Grid.column is a dependency property that is not a property defined on buttons, but we can set it, and the grid will actually look at that and use it to figure out what column we're actually trying to put it in. And I'm going to have my text box, which I'm going to use a text box, not the block, because I want this to be editable. I want you to actually be able to type into it. And grid.column equal to 1. And then a button with grid.column equal to 2. It's going to be my increment. So there I have my 3 buttons, or 2 buttons in my text box. I have kind of the basics of my control. Now let's dip down into the code behind. So count box. I want to have a property to represent the count. And that's probably going to be a uint, because there's no reason to have a negative count in this case. And I will call it count. And if I were to declaring this as an auto property, it would just be a get and a set. That's pretty straightforward. And then I'm going to declare a couple of event handlers for those 2 buttons. So I'm going to go ahead and make these private. The return type of all of these event handlers is always void. And we will say handle increment, which takes an object as the sender. And because this is a WPF object, it's going to be a routed event args. And then inside of that, what I want to do is I want to call that increment, or I want to increment the count. I can just take my count property, throw the increment operator on it, and I'm good. And then I'm going to do the same thing for the decrement. So count and the decrement operator. All right. So that's kind of the basics of hooking up those event handlers. Now, the sharp-eyed programmer might say, well, what if you decrement the count past 0? We really don't want to do that, because that essentially would make it go from 0 to a very large number, because you can't have negative values in an unsigned integer. We'd basically just be rolling over. Or it would throw an exception, one of those two. In either case, we really don't want that to happen. So an easy way of fixing that is just say, hey, if count does not equal to 0, then go ahead and decrement. Well, if we're doing it for the 0 end, we probably should do it for the other end as well. So if count does not equal, and we can actually say uint.max value is the maximum value a uint can actually hold. And you'll find that all the numerics, uint, int, float, double, They all have a max value and a min value, which are just a static field that's declared on the object itself, because those are all actually classes that holds whatever the maximum or minimum is, just so you can use it in tests like this. In fact, we could actually change this from 0 to uint.min value, but 0 is pretty clear to the program, whereas in order to know what the max value is, you need to know that the uint is actually a 16-bit, or actually a 32-bit in this case, uint versus a 16int, which tells you how big it can possibly be. So it's easier just to use those max values and not need to worry about what kind of uint we're actually talking about here, because especially if we get into cross-compilation for different platforms, it may be different across different platforms. So that saves us a little bit of effort. The other thing we might want to do is that routed event args has a handled property. We can set that to true in both these cases. Now, you guys have worked with the routed events enough to know that they bubble up the elements tree. If we set them to handled, if we set the handled value to true, that stops them from bubbling up. So it says, okay, we're done. We don't need to bubble up anymore, and WPF no longer bubbles that event up. And so if this handle increment and handle decrement are only ever supposed to be called from within this control, and they're all internal to this control, it really makes sense to stop them from bubbling outside of the control. So we're just going to go ahead and do that. And that saves us from having to disambiguate if this event came from this control or some other control at other levels. So we'll go ahead and save that. And if we go back to our XAML side, now we can go ahead and hook up not the shopping list, but our count box, XAML. You can hook up those two event handlers. So we want button face dot click. Again, look, it almost looks like a dependency property. It's not. It's a dependency event, but it's a very similar idea. And this one is our decrement, so we're going to use handle decrement there. And this one is button base dot click, and we're going to handle increment because this is our increment operator. And once we have that, we can jump back to our shopping list control. And we can add to our checkbox and our text block this count box, which of course has the local namespace, local colon count box. And what we'd like to do is set its count to be bound to the quantity property that we saw in our line item. And notice that as soon as we do that, it's going to tell us count box doesn't exist. That's because we haven't built yet. So if we go to the build menu and build that solution, that adds it to the local namespace because now it shows up in our control and looks like it's all happy hunky-dory. Let's go ahead and look at our line item, and let's put a breakpoint on this quantity so that we know when that quantity changes. And let's run our shopping list. And a binding cannot be set on the count property of count box. It can only be set on the dependency property of a dependency object. So that tells us right there that bindings are special and they could only be applied to a dependency property. And what we have just defined in our count box is not a dependency property. It is something else. So how do we turn this into a dependency property? Well, we said a dependency property is basically a key value pair, and the key part of that is actually a dependency property. It's its own class, so we can declare an instance of it. We're going to do this right above our count here. Oops. One line down from there. And by convention, a dependency property's name is the name of the property, in this case count, plus the word property after that. So count property equals, and then normally we'd construct a new dependency property. This is what we used to. However, the constructor of a dependency property is not public. We're not actually allowed to call that constructor. Instead, they've set it up with a kind of factory method. You'll learn more about factory methods in 501, but a factory method just allows us to create an object and do some extra work while we're doing that. And the dependency property class has, as that factory method, a register method, which constructs the property but also registers it in this global registry that allows our WPF application and our IntelliSense to actually pull out the information about that. So we would go ahead and do this registration process. Now, this register takes a couple different arguments. The first is the name of the property, and that is the name of the actual property, so in this case, count. We could do that as a string, but we've also been learning to use this name of. And the benefit of using the name of is it converts a symbol, in this case, count, to a string for us, and that helps us avoid typos. So that's just a good strategy there. The second argument is going to be the type of the property itself. This is a uint, so we'd want type of uint to say that it's going to be a uint property, unsigned integer. And then the third argument is the type of the class that actually is defined in, so count box. So again, a type of. And then the next property is, or next argument is a kind of metadata. And that could be a property metadata, or it could be a framework metadata. Because this is a framework element and this dependency property is really meant to be part of that framework, we're going to use a framework metadata. And somewhere in there, I spelled it wrong, so let's try that again. There we go, like a capitalized data. And you can see there are 11 possible constructors for this, so there's a lot of variations. The one we're going to use, and this is true of both framework property and the regular dependency property metadata, the first value is actually the default value for the property. So in this case, we're probably going to start accounts at 0 or 1, depending on what our use case is. Here I'm going to start it at, well, actually, yeah, let's start at 0. 0U. And then we're going to have a framework property metadata options. So this is an enumeration. It has a whole bunch of possible values. But notice that they call it flags. And this is a little bit different use of an enumeration than we've done before. So normally in enumeration, we say it's going to be one of these values, but just one. There is another way of using an enumeration, which is to use it as flags, which is a Boolean bit mask or a bit map, sometimes we call them. But basically using different bits to signify different things. So if that bit is turned on, it signifies something. If it's turned off, it does not signify that. And when you do that, you use the custom values to your enum. So your very first value would be 1. Your next value would be 2. Your next value would be 4. Your next value would be 8. Your next value would be 16. Notice these are powers of 2. So each one of those is a single bit. So 2 is 1, 0. 1 is 1. 8 is 1, 0, 0. 16 is 1, 0, 0, 0, 0. So you can see they all would line up differently if you were to draw them out longhand. And you could do bitwise ORs to say that I want this one and this one to be true. And when we interpret that in the framework, it can actually pull those out and pull those values out. So when we're combining these different ideas, we do that with a bitwise OR. So we, again, use the framework property metadata options. You can see there's a lot of different ones that are in here. The ones we're going to use in this case is effects render, which says changing this property will change how this framework control is rendered, so what it actually looks like on screen. And then the other one we're going to do is framework property metadata. Step to the side here. Oh, there we go. Thank you. Binds 2 ways by default. So that just says this control is going to use a 2-way binding without you having to specify that in the binding. And because we said we wanted this one to be editable, that's really the one that makes the most sense for us. And now we can go ahead and finish off this method. Now this is a very long one. So normally we do everything on one line, but it is acceptable in C#, especially when these start getting long, to actually split out and add new line characters inside of things like a function call. So this just makes it a little more possible for us to read it, makes it easier on the next person to come in. So this is a good idea. Okay, So that allows us to define this dependency property, which is the count property. A couple other things we need to do with a dependency property. It should be public, and it should be static. So we should only have one copy of it defined, which is attached to the class dependency, or to this class itself, so the user control. And that's why when you look at the dependency properties that are being set, they actually have the name of the class and then the name of the property, because that's where that is actually coming from, where they find the keys. You go to the class that defines the key. And then we're also going to set it as read-only. We don't want it to be changed while the program's running. And so those are just standard things we do with the dependency property. We always declare it as public static read-only, and we always call it the name of the property plus the word property, and we register it with this dependency property.register function. Okay, and then we come down here to our count. So instead of using an auto property, we're going to have to expand this out. Now, normally we would expand it out to use a private backing field. However, because this is a dependency object, we're working with dependency properties, we're going to use the value that's stored in that dictionary instead. So in the get, we will return the value that is stored in that dictionary, which we can use the get value method of the dependency property to get that, or of the dependency object. And the key, like we said, is the dependency property. So in this case, count property. So this static property that we just declared up here is the key that we pass in. And we're going to return what's stored there. Now you'll notice that this is going to cause a few complaints when we do that. Specifically, get value returns an object. And this count should be a uint. But we know if we stored it in there, it should already be a uint. So this is a case where it is safe to use parenthetical casting to turn it into a uint before we hand it back. And then our set works similarly, where we're going to call the set value of the dependency object. And in here, we're going to, again, supply the dependency property to identify the key, not property event, count property. And then the second argument to the set is the value you want to set it to. And we're just going to pass forward the value that was passed to this setter. Okay. Now, count is a dependency property. So that is hooked up and should allow us to do binding. We'll go ahead and run this. And notice that we have count here. That's actually a lot bigger than I wanted it to be, but that's okay. And if we change the value, notice it updates. So it started with a value of 1, and now it's going to 2. However, we don't quite have it all hooked up yet. So that is not bound to our line items quantity quite the way we want it to be. We want it to actually pull in that value, display that value. So what piece is missing? Well, if we go back to our control, our count box YAML, this text box does not have a default value. So we could press the plus and minus buttons and we're incrementing and decrementing the property, but it's not being displayed in this text box. And we want it to show up there. So in order for that to display there, we also need to bind this. So we want to say this text box, I want you to be have as your text a binding. And I want to actually bind you to the count property. But the count property is not defined on the data context object like we've done before. Instead, it's defined here in this control. And because it's defined in this control, we're going to adjust the source of the binding. We're going to say, I want you to go to a relative source. So relative to this text box. So going relative basically meaning you're going to climb up the tree or climb down the tree. You're going to find something in the elements tree that I'm looking for. And a relative source property takes a relative source object. So again, in new curly braces, we're now saying we're going to construct a relative source. And it has a couple potential properties. The ancestor type is the one we want. So ancestor types is it's going to be a type of object. If we crawl up the tree looking for an ancestor, as soon as I find one that has this type, that's the one I'm binding to. And what are we going to bind to? Well, in this case, a user control that has the class name of count box. And again, because that is defined in the local namespace, we have to have local colon in front of it. And that basically now says, I want this binding to be bound to the count property of my parent or my ancestor, which is a count box. So now if we run this code, we can see it starts with a value of 1. Now remember, we set the default to 0, so this value is actually being overridden with the bound property, because in the quantity, we start with 1. And then if I increment that, notice the value gets updated, and now it's 2. And if I decrement that, value gets updated, now it's 1. And if I continue decrementing, notice there it tries to set it to 0. And if I decrement it once more, notice that we didn't fire off that value changed event. So that's that little bit of extra control we added to that property that's making that not happen. The other thing we can do here is we could type in a value. So let's say 8. And if I tab away from that control, lose focus, notice it comes in here, and now we're setting that value to 8. Now, and that item is actually 8. What happens if we set it to something that is not a valid value? So something like foo, tab away. Now notice what's going on here. Because we bound this text box to a uint, the text box actually has a little bit of validation built into it, and it says, oh, this is not a legal value for that to actually display. So I'm going to outline everything in red and say, hey, there's a problem here. Notice, too, that we did not actually hit our breakpoint, so it didn't actually try to update the value. It's displaying foo, but what's still being held underneath is a number. And I can prove that to you by hitting plus here, and notice the value is now incremented from the previous 8 that we typed in by hand to 9. So foo never even got entered. If I display that again, now it updated, overwrote the foo in the text box with the bound value. So this is a really nice way of kind of protecting this. And then we can just do some work on making this control look a little bit better. In this case, I think that max value, I made it way too big. So let's go back to the count box, XAML, and let's actually, you know what, let's just take that min width, well, let's set it to 50. So shouldn't be any smaller than that. And if we run that again, let's see what that looks like. That's not bad. And I can add other things like cake to our list. And there we have cake. So yeah, I probably might add some margins and things to make this look a little nicer. Or possibly we do these rows with a different, not a stack panel, because now that we have 3 controls, it's starting to get a little bit silly, or potentially move the count just before that. But you can get the idea that now we've got a functional control, we can go ahead and play with it and make it look good. Now the other nice thing about this is now that we have this functional count control, we can throw that into any other control that we need to represent a count, and we can bind a property to its count property and have that automatically update. So we could use this in our particular WPF project for your restaurant. We could use this in other projects where we need some kind of count. We could change what kind of number we're storing, so it's not a uint, it could be an integer, it could be a floating point. There's a lot of ways we can play with this, a lot of cool stuff that we can do with it. This really just gets us started. And the nice thing is now this is a drop-in control that you can use anywhere else you need. All you have to do is, just like we did in our shopping list, bring in that control and do the binding. That's it. So we write it once, and then we don't have to touch that level of complexity again. So yes, wrapping your head around the dependency property can be a bit daunting, but once you've started using it, it's very easy and very straightforward. It's just following those steps of defining that property, defining the property that goes with the dependency property, and then just using it. So hopefully you found this enlightening, and we'll go ahead and take advantage of this in your homeworks.